Welcome back to our 7th video for chapter 3, chemical reactions and equations. And last time I left you with this homework and I'm sure you got the answers. The first one, the reactants, there are two compounds. Barium takes the place of zinc and zinc takes the place of barium. So this is definitely a double decomposition reaction, and in the products that you obtain will be ZnCl2 and BaSO4. The second one, you find one reactant, silver chloride, breaking down into silver and chlorine. So this is definitely a decomposition reaction. The third one, you find one element and one compound. Iron, that is Fe, displaces copper from copper sulfate solution. So this becomes a displacement reaction. The fourth one, you have water with carbon dioxide, that is two reactants, giving you just one product, that is H2CO3, carbonic acid. So this becomes a combination reaction. Okay, I'm sure all of you got it right. So we continue with our next part, and that is what exactly increases the rate of chemical reaction, which is studied in 8th standard. Okay, and even in the 9th standard. So these are the nature of the reactants depending on what reactants we are using. Size of the particles, is it big size, small size, powdered, whatever. Concentration of the reactant, that is it dilute or concentrated. The temperature, are we increasing the temperature, are we lowering the temperature, and catalysts, certain catalysts which we will talk about. Now talking about the nature of reactants, let us think. Which of these two metals will get corroded easily in water? Is it iron or is it zinc? Yes, the answer is iron. You see iron rusting everywhere, especially in moist climatic conditions. Zinc, on the other hand, is more resistant to corrosion. Which of these two metals will react faster with hydrochloric acid, aluminium or zinc? Yes, we perform this experiment in the lab very often. It is zinc. Okay, now why is it so? This is because of the nature of the reactants. Some reactants are highly reactive, some of them are less reactive. As we study more about metals, we will study about the reactivity series, in which we will see which of the elements are more reactive and which of them are less reactive, like silver, gold. They are very less reactive. Silver is more than gold, of course, but gold hardly reacts with oxygen or moist climate, water, acid, bases. They have no effect on gold normally. Okay. The next factor which influences the rate of chemical reaction is size of the particles. Now, do you remember this diagram? Yes, you had it in the 9th standard. What is this diagram of? You are pouring hydrochloric acid, you have taken marble chips, that is calcium carbonate, and then there is a gas which evolves, which is carbon dioxide. So this is laboratory preparation of carbon dioxide. And carbon dioxide being heavier, it displaces oxygen, okay, or air above, and it settles down. So by displacing air, it takes the position. So as it is heavier, it is collected by upward displacement of air. Now what is taken in the round bottom flask I just mentioned? It is marble chips or calcium carbonate, CaCO3. When will the reaction be faster now? When you take big pieces of marble or Sharbat tiles, it's also called, or if you take powdered calcium carbonate. Yes, the answer is when we take powdered calcium carbonate. The reason is size of the particle. Now how does size of the particle affect the rate of chemical reaction? If you take a big piece, it will hardly have any sides. Okay, because when you pour hydrochloric acid, there are few sides which are exposed to hydrochloric acid. But if you take powder, okay, almost the entire particle is exposed to hydrochloric acid. So smaller size of the particle exposes more surface area for reaction, and therefore smaller the particle, more will be or faster will be the rate of chemical reaction. Now concentration of reactant, the same experiment now once again. When will the rate of reaction be higher? when you take dilute hydrochloric acid or when you take concentrated hydrochloric acid. Okay, dilute acid will also act, but the effervescence that come up will be lesser and slower reaction. It will take a little few seconds to start reacting, but the moment you pour concentrated acid, immediately the reaction starts. Okay, so the rate of chemical reaction can be speeded up even when we take concentrated products reactants. Temperature of the reactants. Again, when will the reaction be faster? When you take cold dilute hydrochloric acid or when you slightly heat it up? Okay, so definitely when you heat it up, the temperature being slightly higher, the reaction will also be higher. Now we need to remember that many chemical reactions speed up with temperature, but there are some reactions where we need to lower the temperature also. Okay, there are very few reactions, but there are reactions where so the temperature plays a major role. Especially many reactions, even our physiological reactions inside our body, takes place at a higher temperature. Okay, optimum temperature. Now we have a reaction here. When limestone is strongly heated, decomposition will take place. Calcium carbonate, when strongly heated, will give you calcium oxide and carbon dioxide. This reaction results in the formation of calcium oxide, which is also called as quicklime, and carbon dioxide, that is CO2. Now carbon dioxide reacts with lime water. That is a typical reaction to understand the gas that is given out as carbon dioxide. When we pass it through lime water, the lime water turns milky. Okay, giving us a solution of calcium hydroxide, that is CaOH by 2, which forms a white precipitate and appears as milky. Okay, the lime water turns milky, giving us calcium carbonate and CaOH by 2. So calcium carbonate precipitate is formed, which turns the lime water milky. Lime water is CaOH by 2. Okay, the solution of lime water, the formula for lime water is CaOH by 2. So you get calcium carbonate in, a white precipitate of calcium carbonate is formed when carbon dioxide is passed through lime water, that is CaOH by 2. Now CaO, calcium oxide, reacts with water first to give us calcium hydroxide, okay, which we call as lime water, plus heat is given out. Now calcium hydroxide reacts with the carbon dioxide, that is lime water reacts with carbon dioxide, and you get a milky white calcium carbonate precipitate along with water. Now think a little, if limestone, that is calcium carbonate, is not heated, will the lime water turn milky? No, the decomposition of calcium carbonate will not happen and you will not get calcium oxide. If you don't get calcium oxide and carbon dioxide gas, the lime water will not turn milky, because only when the calcium carbonate is heated, carbon dioxide will be given out. Okay, and the last one is catalyst. Now what is a catalyst? It is a substance whose mere presence increases the rate of a chemical reaction without actually participating in the reaction. Everybody knows this when a teacher gives you something to do. Okay, when the teacher says, I'll come in 2 minutes, complete this. Surely nobody will complete it, or there will be a very few of you who will complete it. But when teacher comes around and checks who's doing what, your work goes up faster, right? The teacher does not participate, but as a catalyst, the mere presence of the teacher is enough to speed up that work of yours. So in the same way, there are certain catalysts which by mere presence can speed up the reaction without actually participating in the reaction. So you need not write it in the reactant part, you can write it on the arrow. The catalysts are normally written on the arrow. Now on heating, potassium chlorate, KClO3, decomposes very slowly. The rate of this reaction neither increases by reducing the size of the particle nor it increases by increasing the temperature, but if you take manganese dioxide, the mere presence of manganese dioxide will quickly help in the decomposition reaction of potassium chlorate, giving us oxygen gas. Okay, now this definitely magnesium oxide acts as a catalyst. Okay, so no chemical change takes place in MnO2, however. So manganese dioxide remains unchanged. Okay, it does not change at all, but it definitely speeds up the decomposition of potassium chlorate. So we stop here, and in the next video I will take oxidation and reduction reaction. Till then, take care. Bye bye. God bless.